Hello, this is Tommy. Welcome back to Chatomics. I have over 12 years experience of computational biology, and I converted myself from the web biologist to a computational biologist. And today I'm going to show you how to calculate counts per million from scratch for RNAseq or ChIP-seq account table. Okay, usually for RNAseq data, you get this count matrix with the rows are genes, columns as samples, and the entries will be the number of counts for that gene. And for chip sequencing data, you also get this count matrix where the rows are the peaks, columns are the samples, and then the entries will be the number of reads or counts for that peak and for each sample, right? And counts per million is a way to normalize the sequencing depths. So essentially, each column is one sample, and then you just sum up that column, so you get the total number of reads for that sample, and then you divide each entry from that column by that column sum times 1,000,000. Okay, that's essentially how CPM is calculated. So let me show you how to do that from scratch. Okay, and there's also a little I would say trick that you need to learn from R, and you need to pay attention. If you don't pay attention, you may actually get the wrong answer. So make sure you stick to the end. Okay, so first, let's actually create the dummy matrix. Use the matrix function. Okay, and if you look at the matrix, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I specify by row equals to true, so it will feel like by row, so 1, 2, 3, like this. So if you don't specify by row, actually R will fill the numbers by column, so it will be 1, 2, 3, 4, 5, 6, like that. Okay, so we can take a look. Okay? So if we don't specify by row, so it will be like that. So 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay, make sure you actually know those like small little things, okay, in R. So the first way to do it is use the SWIP function in R, okay? So you can read the help page, so by just question mark SWIP, so then you'll find this page, okay? So essentially what you can do, you can actually specify the matrix or array, then specify the margin. Essentially 1 means by row, 2 means by column. Okay, so we specify 2 by column, and this is the stats we're going to swap out. So it's essentially the column sum for that matrix. So if you use column sums of that matrix, then you see this is the column sum for each metric for each column. So 1 plus 4 plus 7 is 12, and 2 plus 5 plus 8 is 15, okay? And here, because we want to actually divide that and then times 1,000,000, so we actually divide 1,000,000 here, okay? And the function will be just here, a dividing function here. So let's do that. And let's take a look. And this is essentially the counts per million for this. Okay. Okay. We can also use apply function. Okay, apply. So let's look at the help page. Okay. So essentially, it's the same thing. You can apply a function, either as array or matrix. Also the same. You can specify the margin. Either is by row or by column, so, right? So 1 indicates rows, 2 indicates columns. And then we specify a function. Essentially, the function will be the x, essentially the column, divided by the sum of that column, and then times 1,000,000. Okay, so we can take a look and print it out. It essentially is the same as the first methods. So we can actually use all the equal all.equal function to test. Normalized mat1 and normalized mat2, and you see it's actually equal, okay? But you can actually directly use vectorization, the feature in R. So essentially you can divide a matrix just by a vector. So essentially column sum will be in the sum of each column, but you have to actually remember the division of a matrix by a vector is actually by row, by default, okay? If you take a look, that's how it looks like. Let's take a look at the original matrix. So essentially, it's actually by row, meaning, okay, 1 divided by 12. Let's calculate this entry here. And then 2 also divided by 12. This is this number here. And then we have 3 also divided by 12. That's 0.25, okay? But this is not what we want, because we want to actually divide each column, right, by the sum of that column. So what we can do is transpose that matrix, okay? If you do transpose, and you actually transpose, and now you can divide it by the column sum and times 10 million, and then transpose it back. Let's take a look. And now, if you compare the previous results, normalized one, now it's the same, right? So you have to be really careful about this. So the division of a matrix by a vector is really it's a row-wise operation. It's not column-wise. So you have to transpose the matrix first, divide the column sum, and transpose it back. Or if you use a well-actually tested package, for example, EdgeR, it has a function called CPM, or counts per million, just to do that for you, okay? Let's take a look. So load the library, CPM mat. Essentially, it's the same as what we calculated from scratch, okay? Okay, so that's it actually for today. I hope you learned something, and make sure you subscribe to the channel, and I will have the link of this R Markdown in the description of this video. So happy learning, and I will see you next time.